Our path to autonomy is long and winding.
3-4 years' time, what that might feel like.
Are there issues? Are there risks? Are there opportunities?
How can we be thinking about how to leverage AI to really amplify human capabilities?
What a loaded question.
How much data are we talking about at the moment?
How much can we put on the car that allows us to have good enough?
What do you think are the toughest bottlenecks right now that can get solved by technology outside of the vehicle?
It's going to be probably a surprising answer.
Welcome to Interconnected. Today, we're diving into the emerging world of autonomy. From driverless taxis in Phoenix to autonomous fleets in Shenzhen, every self-driving mile depends on low-latency networks, local compute, and continuous model retraining. As autonomous technologies rapidly advance, we want to explore where they stand today and how the underlying infrastructure will support their future.
And to help answer that, we're joined by Dr. Bryan Reimer and Petrina Steele. Bryan is a research scientist at the MIT Center for Transportation and Logistics and the MIT Age Lab. He's got a focus on automation, driver behavior, and the future of mobility. And he's the author of the forthcoming book titled How to Make AI Useful, Moving Beyond the Hype to Real Progress in Business, Society, and Life.
And Petrina is Equinix's global lead for emerging technologies. Most recently, she was the global lead for autonomous vehicles and connected tech, where she was responsible for shaping Equinix's connected autonomous vehicles and smart transport strategy. Bryan and Petrina, it's a real pleasure to have you join us. Bryan, what has you most juiced about this autonomous vehicle space?
It's the increasing array of automation-enabled technologies in our vehicle. And this is from Tesla's Autopilot to GM's Super Cruise and Ford's Blue Cruise. Technologies that really can assist us as we wait for automation to really support us more ubiquitously.
Petrina, who are you seeing as the current players shaping the market now, and how do they differentiate themselves?
So when we first looked at the market, it was everyone attacking the market. So everyone was investing in the space, and not only the traditional OEMs, but you had new disruptors coming into the market. I think what's really interesting is to see, the different strategies that each one of these are implementing now. So some of them might have started with, we're going to invest, we're going to build this capability ourselves and run it in-house. And some of them have evolved to say, actually, we're clearly not going to be able to fund that, or we're going to be a late adopter and watch what the market does. And some of them have moved towards partnerships. It's just an sort of moving target that we're watching at the moment.
I think a key piece here is that a little over a decade now, we were going to solve these automation issues overnight. We were going to have fully autonomous, self-driving vehicles moving us from point A to point B, and we weren't going to have to drive anymore. And I think the key here is that over the last decade or so, we've come to a market reality that our path to autonomy is long and winding. While we see organizations like Waymo being highly successful with robotaxis, and we feel that they're growing, in reality, the real meat of the growth is there in assistive driving, where the market is demanding convenience, and hopefully that convenience comes with safety.
Yeah, actually, Petrina, on that note, last I checked, there were no fiber connections from each car up to the cloud. So what do you see? Are there issues? Are there risks? Are there opportunities in that cloud to car connectivity? And what happens in the middle? Is there a place for, is there any physical stuff going on?
What was really interesting about the kind of what compute that you put on the vehicle versus what is off the vehicle. I think also one of the really difficult challenges is that anything on the vehicle then sort of adds weight. So you're actually then changing the design and the flow dynamics of a vehicle. So there's so much complexity in the sort of understanding of not just how much compute goes on that car, but then these cars become more and more expensive. So there is this kind of real balance around how much can we put on the car that allows us to have good enough versus let's go full, and then realize that we're changing everything about the vehicle in itself.
It all comes back to the question of how safe is safe enough and how much investment we need to make in each vehicle, both onboard and offboard the vehicle, to provide the level of support consumers are looking for at a safety equation that meets societal needs. And right now, we just keep investing more and more and more in technology, and the average price of a car in the US is approaching about $50,000 and continuing to explode. So we need to think about how much technology can we bolt on, how much compute, how much sensing, and how can we afford that?
Bryan, when you look globally, what are some of the most advanced autonomy use cases that we're seeing now?
I think the mining industry is actually among the more advanced out there. And that's because the risks of moving heavy trucks and mines has been there for a long time.
My perception of the success of autonomous vehicles in mining is because it's a very controlled environment. They own the environment. There's no random people coming out from behind school buses. So from an infrastructure point of view, they're able to set it up in the best way possible to capture that data at the edge and get it uploaded to the cloud and train and retrain. How are you seeing the evolution of this data loop in real-world autonomous vehicles at the moment?
Simon, I think you pick up on one of the arts of automation is controlling as much as possible as what we call the ODD, or the operational design domain, the design in which you're engineering the automation. The simpler that design domain, the easier the automation problem is. So, if we were trying to automate a small city like Chandler, Arizona, it's a lot easier than trying to automate the entire state of Arizona, let alone the Western Seaboard, multiple cities, et cetera. So mining, as you mentioned, is controlling that ODD as best as they can. We even see the city by city philosophy of Waymo trying to control that to some degree and limit things. But the expansion of the ODD brings enormous complexities.
So, Petrina, what do you think are the toughest bottlenecks right now that can get solved by technology outside, or digital infrastructure outside of the vehicle, to bring about the best possible outcomes? I mean, even if we don't get fully to level 5, right? I mean, I think it's kind of a North Star more than an actual destination. But what has to happen outside of the car to make that work? What do you believe has to happen?
Wow, what a loaded question. I think there's quite a few things, right? So I think Bryan was touching on that sort of how much can you control on the ODD, and I think that's one big element, right? So as we sort of move out, what in the realm can we control? Maybe an airport or a campus or a smart city. I think what's really interesting for me is the countries that have moved very quickly forward are very highly supported by government, right? We mentioned China as one of the market leaders. I'd also like to say the Middle East. Infrastructure is there. So if you look at these areas, a lot of the infrastructure is new, right? Imagine trying to retrofit infrastructure and road layouts. It's not conducive. So I think anything where there is sort of new, easy infrastructure, when I say easy, as in it's been laid out in a way that makes it more controllable. I would also say one of the other things is around open systems, right? Sharing of data. So swarm intelligence is a big thing that people talk about around how do we aggregate all of the data and make it open for others to use. And when that gets to that point, then we have more intelligent systems. So I think there's a lot of different pieces around that need to really come together in order to kind of move the ball forward collectively.
How much data are we talking about that goes back and forth between the car?
I think it's quoted around 4 to 10 terabits per hour of driving of data that's generated. The understanding is that data somehow has to get to the cloud, right? And it can't all be transferred over APIs. And so what has to be created is either from a training model perspective, the ability to ingest that data very quickly. So what we see over time is customers from a test car data perspective trying to actually bring those memory disks and put them directly into a data center. So they actually physically bring those disks in, or they courier those disks, and then they either put them into their own infrastructure that they have, or they put those into an ingest location with one of the hyperscalers. And so that process for being able to do the training sometimes can take so much time, not because of the technology, but because those disks need to be transferred by mail or, shipping to be able to get into the systems. And so the fascination with being able to get that quicker has now leapt multiple folds forward. So we now have what we call ingest stations for these hyperscalers, right? So we recently announced one in Munich with AWS. And so you can understand that's very popular with any companies that are doing very big simulations within the cloud. They want to be able to move that data very quickly. You've got to understand what is it that you're streaming and how can we improve those architectures by building out your infrastructure to be able to have distributed data and allow that ingest towards the cloud and towards your various platforms that you have, but also on the training side to be able to do that and get that data very quickly into your big systems. They both overlap, but they're separate currently.
Let's look forward. As autonomy becomes a little bit more part of people's daily lives, I'd love to hear what you guys think it's gonna look like. So Bryan, let's start with you. What becomes invisible and just works?
So I think it's really the collaboration between humans and machines that's going to evolve the most over the next few years. Automation, AI technologies are going to, make us better decision makers on a moment-to-moment basis. The car stepping in and saying, Glenn, I know you're looking at your phone right now, and I'm going to do things to help support you. Maybe you should put that down, or maybe the car in front of you is slamming on the brakes, so we're just going to buy the smallest smidgen, delay that incoming phone call, so that you are attuned to what you need to be doing more effectively. The seamless integration of edge cases of AI into our lives through driving and other technologies. And the reason I say edge cases is because these are going to be actually huge components, but just the tip of the iceberg.
What do you think has to happen from an infrastructure perspective to make all this happen?
So to make it happen is that we are going to need to get faster speed pipes to all of our houses, all of our lives. It is all about the pipes. Here we are. We've all been driving with smartphones in our pockets for years, cell phones in our vehicles for probably best part 2 decades now for many of us. And we still run into gaps in services constantly. The phone is not a seamless connectivity device. We have to solve the delays in connectivity so that we can begin to rely on the automation and the AI that sits around us.
I envisage a world whereby an AI agent will look at my agenda and then say, I need to order your car or, send you a bleep to make sure your car is ready, and I'll have that map uploaded. I feel like that's where I'm most excited, is to get that seamless integration between different systems that would then work together. There's so much going on within vehicle innovation around being able to sense the health of a passenger, right? So is my passenger becoming more stressed? Shall I play some ambient music to de-stress you? Is your heart rate, rising for any reason? I feel like that is where I'm most excited.
In your opinion, what do you think is the best way that we can address the latency concerns?
As Bryan said, one is the element of how do we connect up all of this digital infrastructure, right? How do we ensure that there is better ubiquitous connectivity? There is more investment around, getting better access to different platforms. I think that's where we'll start to see a lot of rollout over the next 5 to 10 years. All of the investments around subsea, all of the investments coming in around data center, fiber, hollow core fiber, all of these investments are sort of layering on top of each other to enable us to get to the point of autonomy, should we want to have it.
When we think about these technological trends, we are, in essence, as humans, are our worst enemy. We continue to debate and push for our perfect answer from my organization, as opposed to being willing to step back and say, from a societal perspective, let's just pick a direction and go. Either one can provide good answers and better where we are today. It's our relationship with these technologies and the question, are we willing to change, that is really pivotal to the acceleration and deployment of everything from autonomy to AI in the future.
Everyone is building their own little siloed walled gardens today. And the only time we can unlock those is when people start looking at how we openly share data. The ability to do that then unlocks so much. So I think that is one of the ways about looking at how we can open out the technology for everyone. And when that happens, I think innovation and things will move much faster.
Our listeners have gotten quite a lot to digest. We're looking forward to hopefully in the future following up on this and seeing how we did on some of the predictions and directions that we put forward. Thanks to our guests for joining us today to help us explore the growing landscape of autonomous innovation and how it's rapidly changing how the world moves.
And stay tuned for our next episode of Interconnected, where we will look at another technology megatrend and how it intersects with digital infrastructure. You can find all our episodes on the Interconnected YouTube page and wherever you find your podcasts.